For this review problem, we'll look at the product in black of 3,316,624,791 times 5,099,019,541. Now this is a fairly long problem. If we try to just simply multiply this in the calculator, 316624,791 times the other number, 5099019541. I think I typed it in correctly. We get something that's on the order of 1 times 10 to the 19th. So that's going to be the approximate answer, but the calculator does not return all 20 digits that appear in the product. So how do we get this answer without doing the multiplication that we know and love since 4th grade? To do this, let's take a look at the problem in red just to kind of introduce ourselves to the idea. So just remind ourselves of how we do 37 times 85. So 7 times 5 is 35. I bring down one digit, and then I'll bring up one digit for 3. 5 times 3 is 15, plus 3 makes 18. Then we'll do it again. 8 times 7 is 56. I'll put the extra 0 here corresponding to the 80 and 85. I will now carrying the 5. 8 times 3 is 24, plus 5 makes 29. And then adding up, we get 5, bring down the 4, carry the 1, we get 1, carry the 1, and we get the final answer of 3,145. And this better check, 37 times 85 is indeed equal to 3,145. Okay, that's well and good. The way that we're going to tackle this more complicated problem is not by looking at one digit at a time, but 5 digits at a time. So I'm going to break these up into blocks of 5 digits, and I chose 5 digits because our calculator has at maximum 5 plus 5, 10 digits that it can show at once. And so just like here, I did 7 times 5. Let me do the first block of numbers, 24791, the first block of numbers, times the second, the laddered block of numbers, 19541. And this gives me a big product. The last 5 digits I will put down. So 4409. I'm sorry, I put down one too many. Let's start over again. 40931. And then the previous 5 digits, or in this case 4 digits, go up to carry. So 4844. Now I do it again with this first block times this block. So 33166 times 19541 plus the thing that I carried, 4844. And that gives me this next number, which I will put down. So writing this carefully, I have 648101650. And we separate the blocks of digits 5 at a time just to kind of keep track of the arithmetic. Okay, so that's the first part of the problem. Now we do it again. Over here I multiplied by 80. Now I'm going to multiply by 5,999, or actually 5,990,000,000. 5,099,000,000, that's what I said. Alright, so let's go ahead and do it. So next part, 24791 times 50990. And so this gives me a product. I'll put down the trailing zeros here, just like I put down the trailing 0 over in this problem. And then the first 5 digits start at 93090. That goes down here. 93090. And what gets carried, I don't need this anymore, what's get carried is the 12640. So those 5 digits get carried. And then I multiply the digits here, so 33166 times 50990. And then I add the thing I carry, 12640. And this gives me the next block, so I have 16911 46980. And I'll put a comma here and a comma here. Now lastly, we have to add these things. Well, first off, the bottom here is easy, 40931. In much the same way that bringing the first 5 down here was easy. Okay, next we have these blocks of 10 digits to add. We now add the digits, so we have, so starting on the 6, we have 648101650. Then I'll add that to the number down here, 46980939090. And that gives me a sum of 53461 94740. And then notice the last 5 digits kind of carry, 16911. Here the problem was fairly straightforward because the middle 10 digits gave me a sum here that had 10 digits. So of course, sometimes if you have a 10-digit number plus a 10-digit number, the sum might be an 11-digit number, and that would go off the range of the calculator, so just have to be careful about that. Anyway, there is the answer, and it's all its glory, separated in blocks of 5 digits. As a quick check of our work, let's use Mathematica. So here is, again, 3,316,624,791 times 5,099,019,541. And if we do the product, we get indeed the same answer that we just got by hand. 16911, 534, 619, 474, 040931, which entirely matches the answer that we just got. So this technique is basically using base 100,000 instead of base 10 and technology to be able to mimic the process of multiplication that was taught in 4th grade, but being able to do this for bigger numbers, but without being as painful as doing this one digit at a time.